Welcome to our lesson 6 on integration, a lesson where we are going to look at application of integration in determination of area under a curve. We have looked at various ways of estimating area in the topic area approximations. In particular, we have looked at middle unit rule. We have looked at the trapezium rule as ways of estimating area. Now, when we now apply integration in determination of area, I want you to understand that here we are going to apply more the idea of definite integration to be able to get area under a curve, because when we are supposed to get area under a curve, bounds must be given, otherwise the area remains indefinite. We must be told get the area but from this point to this point. That brings in the aspect of definite integration. And that means that the bulk of the work we are going to do here is simply definite integration. Only that now it is specific to the determination of area under a curve. So we are noting that the idea of definite integration is used in determination of area under a curve, and I've explained why. Definite integration is where we have limits of integration given. Area under a curve cannot be determined if the limits or the bounds are not given. When we are given an area under a curve to determine, we integrate the equation of the curve. That curve will have an equation. It is that equation that we are going to integrate with the limits given or determined. I'm saying determined because we are going to look at various aspects of area under a curve. We shall have cases where the limits are explicitly given in the equation. In some cases, the limits will not be explicitly given, and as a student, you will be required to determine them. So we are saying we shall be integrating with the limits which may be given or may be determined by the candidate. Then we shall substitute the limits in the integral and simplify to obtain the area that we are talking about. So you can see where substitution and simplification comes in, because under definite integration we were simplifying, we were substituting and then simplifying. So after integration we shall substitute and then simplify. In some cases, when we integrate and simplify, the final result that we may get as area could be a negative result. And this sometimes is a confusion to the candidates. When you see a negative result, you wonder whether area can be negative. I want to assure you that area cannot be negative. And so, when we get a negative result, we shall drop that negative. But what is the meaning of a negative area? A negative area in our calculation, if you find it, simply means that that area that we have determined is below the x-axis. That is when it becomes a negative result, and as I've said, we drop that negative. We are noting here that unlike in trapezium rule and middle unit rule, where the area we get is an approximation of the accurate area, integration is now used to determine the exact area. So area by integration is called exact area. I want us to look at just two examples. We look at various aspects of these examples to highlight what I want you to understand. The first example is going to look at area when the region whose area we want to determine is on one side of the x-axis and it is on the upper side of the x-axis. we anticipate to get a positive result. But I want us to see the processes involved. Look at the curve. It is a curve of the function y is equal to negative x squared plus 5x. Y is equal to negative x squared plus 5x, which is a quadratic function. When you look at the way it is drawn, it is requiring us to get the shaded area. The shaded area is bounded from 0 to 5. 0 to 5 now become our limits of integration. So I want you to see where the definite integration now comes in. Because now we are going to integrate, but with the limits from 0 to 5, we are saying that area is equal to the integral from 0 to 5 of minus x squared plus 5x. This is the function for this curve, this quadratic function, minus x squared plus 5x. So the next step is integration of that function. X here is raised to power 2, so it becomes x power 3 divided by 3 plus 5x, x is raised to power 1. When you add 1, it will be power 2 divided by 2 plus the constant c with the limits from 0 to 5. The next step we have done when we are doing definite integration. So we have minus 5 cubed, because we are substituting where there is x, we place 5, the upper limit. We've done that in the first bracket. In the second bracket, I've shortened the work, so you can only see 0 plus c. Why? Because when you substitute 0, in the first term and the second term, the result will be 0. So I didn't want to write 0 plus c. I therefore simply wrote 0 plus c in the second bracket. When you move to the next stage, we are simplifying. And I want you to again follow with your calculator. We have simplified, and in the next bracket, where we have 0 plus c, the result will be negative c. As I told you, c and c will be 0 after subtraction, and the result we get is 20 and 5 over 6 square units. That is now the area bounded by that curve and the x-axis from x is equal to 0 to x is equal to 5 by integration. Let us look at example number 2. In our example number 2, we are looking at area bounded by the curve and the x-axis. We are looking at the shaded area. But I want you to see that that region is below the x-axis. I want us to use this example to confirm that when the region whose area we want to determine is below the x-axis, we expect a negative result which only indicates where the region lies, but it's not indicative of the area. That is why eventually we drop that negative. But now, if you look at it, the way it is drawn, it is ranging from 2 to 4. That shaded part which is below the x-axis is ranging from when x is 2 to x is 4. So 2 and 4 become our limits of integration, with 4 being the upper limit and 2 being the lower limit. So it is integration from 2 to 4, x squared minus 6x plus 8, which is the function whose curve has been drawn there. So we integrate that function. We integrate that function, the normal process of integration. X is raised to power 2, so you divide by 3 after adding 1 to that power. Here x is power 1, so it will be x squared over 2 plus 8x plus c with limits from 2 to 4. In the next step, we are substituting, in the first bracket, substituting the upper limit 4, Where there is x, we place 4. Please, I want you to follow the substitution in the first bracket plus a constant. Follow the substitution in the second bracket. Where there is x, we are putting 2, the lower limit. Check through plus a constant. The next step is simplification. Please follow through. And as you follow through, you must do it. These things you cannot see with your eyes. You follow with the calculator. You may even detect some problems in the calculation, but the process remains the same. I want you to follow. We shall end up with 5 1/3 plus a constant in the first bracket. And when you open the other bracket, it is minus 6 2/3 minus c. C minus c will be 0. And 5 1/3 minus 6 2/3 will be -1 and 1/3. Which, as I've told you, simply indicates that the area, the region whose area we were finding, lies below the x-axis. And so we drop that negative and end up with 1 and 1/3 as the area. Remember, I told you from the beginning that area cannot be negative. And that is why we are dropping that negative. In our next class, we are going to look at when we have a portion of the area above the x-axis and a portion of that area below the x-axis. We shall find out what do we do in that case. And we shall also look at situations where the curves are intersecting regions. Then finally, in area, we shall look at cases where a function is given, the limits of integration are not given. It becomes your business to determine those limits of integration. That work we shall do in our next class. But for now, I want us to end there and look at exercise 10.3 in KLB book 4, page 234. If you look at number 1 to F, some of them, the 2 of them, we have already done here, but you can go there and follow through. Graphs are already drawn there for you. Yours is to just determine the area. They are highlighting some of the things we have talked about and some of the things we shall talk about in our next class. I want to wish you well, and may God bless you abundantly.